Okay, folks, so today we are talking about section 8.2, which is special right triangles. Now, the reason these are called special right triangles is because they have some shortcuts associated with them. It's not just a triangle that we use the Pythagorean theorem on, although the Pythagorean theorem would work. We have some other options for how to solve these triangles because they always fall in a pattern. So the one we're going to talk about today is called the 45-45-90 triangle. And the reason it's called that, of course, is because that is what the angles are. If you take a look here, you see that our angles are 45, 45, and 90 degrees. And so that's why it's called a 45-45-90. Something else that I want you to look at here, something else that you should notice, is that these two sides are the same length. These two legs of the right triangle are the exact same length. And again, you know the base angles are congruent, and so the sides opposite the base angles are congruent. That is making this an isosceles triangle. And so another way to talk about a 45-45-90 triangle is an isosceles right triangle. Okay, that's what these are, an isosceles right triangle. So this equation over here, it is correct, but I want to show you another way of working it. Okay, so I don't use that equation. I like to use special right triangles in regards to similarity, like we did in a previous unit. Okay, we've talked about similar triangles before, setting up proportions and solving those proportions. Well, that's what we're going to do here. And the first thing I want to show you is that what if I said that the legs of this isosceles triangle are 1? Okay, so they're both going to be 1. And now I want to know, well, what's the length of the hypotenuse? Well, to find that, I can use my Pythagorean theorem. So a squared plus b squared equals c squared. And that's going to be 1 squared plus 1 squared equals c squared. Remember, in the Pythagorean theorem, c is always the hypotenuse. And so if I work this out, 1 squared is 1, 1 squared is 1, I get c squared. So this is 2, which is c squared. And then to solve for c, I've got to take the square root of both sides. And so I get the square root of 2 equals c. And so then that's my hypotenuse. So looking at this, if the legs are 1s, the hypotenuse is going to be the length of the square root of 2. And that is important. That is significant. This is the square root of 2. Get rid of that s. All right. And so that gives us 3 numbers, 1, 1, square root of 2, that essentially match up with this isosceles right triangle. And every single isosceles right triangle, or every single 45-45-90 triangle, will be similar to this triangle. Has to be. Remember, because of angle similarity. We've talked about that before. And so what we can do then is set up that similarity problem in a problem like this. And I can say, all right, well, I see that I have a 45-45-90 triangle. And so then I can set up my proportions because I know that this 45-45-90 triangle is going to be, and let me see here. Here we go. That's a little better. Is going to be similar to this 45-45-90 triangle. 1, 1 square root of 2. And so I'm going to put 1, 1 square root of 2 on the top of my proportion. And then the bottom of my proportion is going to go the information from this triangle. So I see that my legs are going to be 9 and 9. And so I have 9 and 9 because the hypotenuse is the square root of 2. So the length of my hypotenuse has to go below the square root of 2. So that's h. That's what I'm solving for. And now I just need to pick two fractions to work with. And I'm going to pick these two right here, of course, because they're just right next to each other. And I can cross multiply. 1 times h, and then I'm going to take 9 times the square root of 2. And so 1 times h gives me h, and 9 times the square root of 2 gives me 9 square root of 2. And there you go, folks. That is our answer. All right, and that's all there was to it. So let's try another one. Coming over here. Again, notice we have a 45, 45, 90 triangle. So that means it is going to be similar to this one, 1, 1, square root of 2. The 45, 45, 90 isosceles triangle. So 1, 1, square root of 2, that's going to go on the top of my proportions. 1, 1, square root of 2. And on the bottom is going to go my information. Now notice, one leg is 2 square root of 2. That means this other leg is also 2 square root of 2. So I've got 2 square root of 2, 2 square root of 2. And then the hypotenuse that I'm looking for is x. I'm going to grab two fractions and cross multiply. And so x times 1 is x. Now I've got 2 square root of 2 times the square root of 2. Now that you got to remember back to working with our square roots. So the square root of 2 times the square root of 2 gives me the square root of 4. But the square root of 4 is 2. So I've got 2 times 2. And so that means I'm going to have an answer of 4. Okay, that's how we do that. Okay, so notice that in these two examples, we were solving for the hypotenuse. Now, of course, that's not always going to be the case. So let's take a look at this example. Now they give us the hypotenuse, but we need to find one of the legs. Now, since this is an isosceles right triangle, and again, I know it is because the base angles are congruent, so that makes it an isosceles triangle, I know that this side must also be the length of x, whatever that is. That's what we're trying to solve for. So let's set up our proportion. Again, the whole point of this section is that we know that this triangle we're working with is similar to that one. We know it is by angle-angle similarity. And so I can set up my proportion using those lengths, 1, 1, square root of 2. And so now the legs are x's. So x, x, and then 6 is the hypotenuse. Remember, I don't need to solve both of these fractions because x is the same number. So just like before, I just need to grab two fractions and solve it. And I'm going to cross multiply here. And I always like to start with my variable. I always multiply my variable first. So that means I have x times the square root of 2 equals 6 times 1. We are not done. In the last couple of problems, we were always done after that first step. Okay? Well, now we're not. We still got to solve for x. So I'm going to divide both sides, excuse me, by the square root of 2. And so this cancels out. And I get x equals. Well, now I have to work with that 6 divided by the square root of 2. That's what I have. I've got 6 divided by the square root of 2. And sometimes they might ask you to give a decimal answer, which is fine. Then you just plug this into the calculator. But oftentimes, I'm going to ask for a reduced radical. And if I ask for a reduced radical, then you need to do what we call rationalizing this step. And so that means I've got to multiply this fraction by the square root of 2 over the square root of 2. Things to remember. This fraction is equivalent to 1. So we're just taking our fraction and multiplying it by 1. So we're not changing it. We're just going to change what it looks like. And so the way you multiply fractions, if you don't remember, is you multiply straight across the top, straight across the bottom. So this gives me 6 square root of 2 over, and again, we've seen this before. Square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 is 2. And don't forget, you can reduce this fraction. 2 goes into 6 3 times, and so our value for x here is going to end up being 3 square root of 2. Okay, so I have one more example for you. It's on the next page. Up here at the top. A high school softball diamond is a square. The distance from base to base is 60 feet. So for example here, for those of you maybe not familiar with softball or baseball, so this is going to be first base, here is your second base, here is third base, and here is home plate. Okay, and so the distance between the bases is 60 feet. To the nearest foot, how far does a catcher throw the ball from home plate to second base? And so right there, we're looking for the distance there on that dotted line. So the key to this problem is knowing that this is an isosceles right triangle. They told us we're dealing with a square. A baseball diamond or a softball diamond is a square. So that means that's a 90-degree angle. And we know the distance between the bases are 60 feet. So this is an isosceles right triangle, which means it has to be a 45, 45, 90 triangle. So, just like the other problems, we're going to start this by setting up our proportion of 1, 1, square root of 2, and then we put in our information. 60, 60, and we are solving for the hypotenuse. Remember, the hypotenuse is always opposite that 90-degree angle. So we're solving for the hypotenuse, which is D. Grab your two fractions, cross, multiply. And so D is going to equal 60 square root of 2 feet. But here's the thing. That is an exact answer written in simplest radical form. These are words that you have heard me say before. That's an exact answer. They didn't want an exact answer. They wanted it rounded to the nearest foot. So we need to grab our calculators and we need to actually multiply that out. 60 times the square root of 2. And according to my calculations, that is going to give us a distance of 84.8528 blah, blah, blah. But they said round to the nearest foot. So rounding to the nearest whole number is what they mean, and that means this number right here. And so again, proper rounding, folks, remember, if you're rounding to this place, you have to look at the number after it. And that number is an 8. So since it's 5 or bigger, we need to round up. So our distance is going to be 85 feet, approximately. So there we go. That is the 45, 45, 90 special right triangle. Please remember that every 45, 45, 90 special right triangle is always going to be similar to this triangle. That is a horrible triangle. Let me try that again, folks. This is just going to be just as bad, but slightly better. There we go. All right. So every 45, 45, 90 triangle is going to be similar to this one. It's a right triangle with the legs of 1, and the hypotenuse is the square root of 2. And the way you're going to set up every one of these problems is by writing a proportion where the top of your proportion is 1, 1, square root of 2, and the bottom of your proportion is the information from your triangle given in the problem. Okay? Give it a shot.